Hey again everybody, now that you've completed lesson 3.1, we're going to have a bit of a summary again as before of the key points that we've learned in this lesson before moving on. This lesson has been all about Earth's magnetic field and the solar wind arriving at Earth's magnetosphere. First of all, we learned that Earth has a magnetic field like the Sun, generated in a slightly different way. The core of the Earth is solid. But surrounding that solid inner core is an outer liquid core consisting of molten iron and molten nickel. Now, usually when these metals are molten, they're no longer magnetic. But the thing is, because there's heat differences and density differences and all of that going on in there, the metals are convecting, they're moving around, and this movement generates an electric current. Now, as Earth rotates, it spins this current around, and that's what generates Earth's magnetic field, the movement of these molten metals and the spinning of planet Earth. Planet Earth's magnetic field is shaped like a dipole magnet, or at least it should be, but it's constantly buffered by the solar wind. The solar wind pushes on Earth's magnetic field, stretching it back into a windsock shape, and that windsock shape is known as the magnetotail. This field, this magnetic field, deflects most of the harmful solar wind around Earth, which is critical. Very, very important for life on Earth. In fact, if we didn't have our magnetic field, you wouldn't be sitting here completing this course. Life as we know it simply wouldn't exist because solar wind is harmful radiation at the end of the day. So this is our magnetic shield. You could think of it as a shield deflecting harmful radiation. So as I said, the solar wind is being buffered. Earth's magnetic field is being buffered by the solar wind all the time. And where the sun's magnetic field, the solar wind, meets that of Earth is called the magnetopause. So there's a couple of expressions to familiarize yourself with. The magnetopause, where the two fields meet, and the magnetotail, that windsock effect generated by the buffering from the solar wind. So, when a large coronal mass ejection arrives, it further distorts Earth's magnetic field. It compresses it on the day side of the planet and pinches the magnetotail together. And in this NASA animation, we get a good sense of what's happening here. So this is quite quiet at the moment. In comes a coronal mass ejection, a CME. And we can see now the magnetopause is pushed much closer to Earth on the day side, and the magnetotail is pinched towards the equator. We've got that windsock effect. The red colour represents a high density of solar wind, the blue colour less dense solar wind. Those vertical lines on the left, that represents the magnetic field of the sun itself. And the other more messy lines, that's Earth's magnetosphere. You can see there they're connecting up at the poles. And you can also see, I don't know if you can see there, the two magnetic fields are interacting. They're talking to each other. They're connecting, and that's the important thing. When these magnetic fields interact and connect, the electrons are accelerated down those field lines to our magnetic north and south poles, where they are allowed access to our atmosphere, triggering the aurora. This is a really, really useful animation by NASA. But some of you might also find it quite busy. There's a lot going on there. There's a lot of different field lines. There's a lot of different color differentiation. So I'm also going to show you a more simplified version of what's going on here. We can see Earth's magnetic field, and we can also see the solar wind coming in and its field represented. And can you see it's pointing in the opposite direction? It's pointing south in contrast to Earth's north pointing magnetosphere. When the north-south poles meet, they connect, and you can see there a representation of the charged particles being funneled down those field lines, and now the field lines are also pinching at the magnetotail, and again they reconnect, allowing the electrons into the magnetic poles, into the polar atmosphere, triggering our aurora. But my favorite animation of this effect is this one, because this really gives you a good insight into how the magnetic fields are behaving. Moving from left to right there, we've got the magnetic field of the solar wind, and now that we're zooming in, we can see on the day side, the magnetosphere of Earth is being compressed, the two fields are interacting and linking up again. And when they link up, when they reconnect, that's referred to as an X point because of the shape of the magnetic field. There, when they meet up, it looks a little bit like an X. It's also referred to as a magnetic explosion, this. These X points are also referred to as cracks in Earth's magnetic field because it allows the solar wind to flow down those field lines. And now again we're seeing this pinching effect represented in the magnetotail on the night side of planet Earth, and they meet there, did you see that? And at that point again the electrons are getting funneled into Earth's polar atmospheres. So in a nutshell, that's how the magnetic field of the solar wind interacts with Earth's magnetic field, allowing the charged particles into our atmosphere and triggering the aurora. So again, well done for completing lesson 3.1. In the next lesson, we're going to look at what happens to the solar wind when it enters the Earth's atmosphere and how it triggers the aurora. So I will see you at the end of lesson 3.2 for a bit of a summary on all of that. See you later.